Assalamu alaikum. We will talk about chapter 9, section 2 and 3 altogether, talking about ideal stoichiometric calculation. I will teach you a technique you can use to solve any stoichiometric problem. And I will teach you the technique on the reaction equation itself. For example, if you have carbon dioxide, this reaction, carbon dioxide plus lithium hydroxide, carbon dioxide react with lithium hydroxide to give lithium carbonate, LiCO3, okay, Li2 because carbonate is divalent, and water. Okay, so this is the equation. Carbon dioxide react with lithium hydroxide to give lithium carbonate and water as product. So step number one is to balance the equation. Must be. You have to make sure that the equation is balanced. So here, for example, you have lithium 2, so you have to multiply this by 2. And now carbon is balanced, lithium is balanced 2 and 2. Let us see the hydrogen. Also hydrogen is balanced, 2 hydrogen here and 2 hydrogen here. Okay, and what about the oxygen? You have 2 oxygen here and you have 2 oxygen here, so you have 4 oxygen in the product, and here in the reactant, sorry, in the product you have a 3 here and 1 here in the water, so you have also 4 oxygen. So now the equation is balanced. So step number one, balanced equation. Number 2, put the mole ratio, and the mole ratio is the ratio of the coefficient. Mole ratio, this means that 1 mole of carbon dioxide react with 2 moles of lithium hydroxide to give 1 mole of lithium carbonate and 1 mole of water. Okay, now what does he want? He says that how many moles of lithium hydroxide are required to react with a 20 mole of carbon dioxide. Okay, so I will write number 3. He gave me 20 mole of carbon dioxide, and he wants how many moles of lithium hydroxide. Okay, so apply the mole ratio. If each 1 mole of carbon dioxide react with 2 moles of lithium hydroxide, so 20 moles react with how much? Cross multiplication. So the number of lithium hydroxide produced equal 20 times 2 over 1 equal 40 moles. That easy. Okay, another example. He says, this is another example. He says, he's talking about photosynthesis reaction. In photosynthesis reaction, carbon dioxide react with water. Okay, this is example found page 306 in your textbook to give sugar C6H12O6 plus oxygen. This is a photosynthesis equation. So number 1, before I said anything, I have to balance the equation. So here you have 6 carbon in the sugar, so multiply this by 6, and you have 12 hydrogen here, so also multiply this by 6 to have 12 hydrogen. And then count the oxygen in the reactant, 6 multiply 2 equal 12 plus 6 oxygen in the water, this is 18. You have already 6 in the sugar, so you need 12 more, so multiply this. What did I do here? This is oxygen 2, so you multiply this by 6. Now the equation is balanced. This is the first step. Number 2, write yes, the mole ratio. You have to make this step. So this means that 6 mole of carbon dioxide react with 6 mole of water to give 1 mole of sugar and 6 mole of oxygen. Can this be simplified more than this? It cannot be simplified more than this. Okay, after I made the balanced chemical equation and I put the mole ratio, then I started to see what does he want. His question is, what mass in gram of glucose He wants the mass in gram, and this means that in this step, as long as he's talking about mass, so I will convert the mole ratio into mass ratio. I can convert mole to mass, yes, for sure, because I still remember this equation, number of moles equal mass over molar mass, you remember? Okay, so 6 multiply, the mole ratio is 6 mole, multiply, what is the molar mass of carbon dioxide? Oxygen, oxygen 16 multiply 2, يعني 32, and the 12 on oxygen, on carbon يبقى 44. Okay, 2. This react with 6 mole of water, يعني 6 multiply 18, 16 oxygen, and the 2 hydrogen 1 and 1, so 18 gram. So it gives the molar mass of the sugar is 180, as I believe. Yes, can we make it? 6, make sure. 16 times 6, this is 90, plus 12 times 1 for the hydrogen, plus 12 times 6, 72 for carbon. So how many grams? Again, 12 times 6, make it with me. 12 times 6, this is 72, plus 1 times 12, يعني 12, add 12, plus 16 times 6, يعني add 90. So what is the total? You do it with me. No, it's approximately 180 gram per mole. Okay, plus 180 gram. Now, let us put here gram, 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 and here 6 multiplied by 16 times 2, 32. Okay, and we have 6 mole, يبقى 6 times 32 gram. So what I did here in this step, I converted the mole ratio to mass ratio. So why I made this? We didn't make it in the previous example because he is talking about the mass of the sugar. So the question says, what mass in gram of glucose is produced when 3 moles of water, يعني كم جرام? 18 times 3, 54. Right? So he says what mass of glucose is produced when 54 gram of water. Okay, so I will take the water and the glucose. So I say each 6 times 18, how much? 6 times 18? Okay, so 118, I will make it like this. The ratio of water to glucose, as mole ratio, it is 6 to 1. As mass ratio, it is 108. This is if you multiply 6 by 18, this is the mass of 6 mole. 108 gram of water will produce 180 gram of glucose, right? So first I made the mole ratio, 6 to 1. And then I converted it to mass ratio using this equation. So the 6 mole of water means 6 times 18 means 108 grams. 1 mole of glucose means 180 gram of glucose. So the mass ratio of water to glucose is 108 to 180. I don't have 108. I have only 54 gram. So this gives how much? Cross multiplication. Okay, now you see, because he gave me the water in gram and he wants the mass of glucose in gram, so this is why I converted the mole ratio into mass ratio. Okay, so how many grams? It will be half of it. So it will be 90 gram. 90 gram. If each 108 gram of water gives 180 gram of glucose, so the 54 gram of water will give 90 gram of glucose. Okay. طيب. Another example. What mass of calcium dioxide in gram is needed to react with the 3 moles of water in the photosynthesis reaction? If I have, so again, the equation is the photosynthesis equation. Carbon dioxide plus water gives sugar, C6H12O6 plus oxygen. And again, this is the balancing of the equation. And again, this is the mole ratio, 6 to 6 to 1 to 6. And now after I make the balanced chemical equation and I put the mole ratio, I started to see what exactly he wants. He wants what is the mass of carbon dioxide react to the 3 moles of water. Type. So carbon dioxide, 2 water, 6 to 6 means 1 to 1. So I have, he gave me, remember? He gave me 3 moles of water. So 3 moles of water react with how many moles of carbon dioxide? It reacts with 3. 3 moles. But he doesn't want the number of moles of carbon dioxide, he wants the mass of the carbon dioxide. So the mass in this case equal number of moles multiply by molar mass. So number of moles are 3. 3 moles produce 3 moles of carbon dioxide react with 3 moles of water. And this 3 moles of carbon dioxide has mass of 3. Multiply the molar mass of carbon dioxide is 44. 16 plus 2, 16 times 2 plus 12. So 3 multiply 44 equal, yes, do it with me. Yes, 132 gram because he wants the mass. Okay. Fine. Let us take another example again and again. Okay, page 309 in your textbook, he gave me this equation. Ammonia reacts with oxygen to give, okay, it's not clear. Okay. React with oxygen to give NO, nitrogen oxide, plus water. Right. This is the equation. First of all, and before I read the question, I balance the equation. How to balance the equation? Let us check. How many hydrogen you have here? 2, and here 3, right? So what is the common factor between 2 and 3? 6, yes? Okay. So I will multiply this by 3 and this by 2. Okay. Then now we balanced the hydrogen. And here the 2 nitrogen, here 1, so we multiply this by 2. Now we balance the nitrogen. And oxygen, here you have 4, but here you have 3 and 2, 5. Type. This means that I need to multiply all the equation again by 2. So if I try this, and we will give you the equation balanced, don't worry. Sorry. So if we make this 4, and this 2, okay, no, here we have 5, right? The 3 and 2 means, let us try this. 5, I can make them, I can make this 10, so I multiply this by 5, okay, and I make this 4, and I make this 6. Let us check again. So now here you have 4 nitrogen, and here you have 4 nitrogen. Nitrogen is okay. And then here you have a 12 hydrogen, and here you have a 12 hydrogen in the product. Now hydrogen is okay. And here you have 10 oxygen, and here you have 10 oxygen also, 6 in the water and 4 in NO. Now the equation is balancing. Number 2, yes, say with me, yes, right you are. I have to put the mole ratio before anything. This is the mole ratio. This means that 4 mole of ammonia react with 5 mole of oxygen to give 4 mole of nitrogen oxide and 6 mole of water, right? So after I do this, I started to see what exactly he wants. The first request is how many moles of NO are formed when he use 8 to 4 gram of ammonia. He gave me, since he used masses, so this means that I need to convert the mole into mass. This is the mole ratio. I need to convert it into mass ratio. So what is the mass of 4 moles of ammonia? So it will be 4 multiply the molar mass. Nitrogen is 14 and hydrogen is 1 multiplied by 3. So it is equal to 17 all in all, the molar mass. So this is the mass of 4 mole, right? Type. How many moles of NO are formed? Type. So this mass gives this number of mole, 4 moles. Sorry. Okay. This mass of ammonia, 4 moles, gives 4 moles of NO. If I don't have this, he gave me how much? 8 to 4 gram. 8 to 4 gram. This gives how many moles? See? So again, after balancing the equation, I put the mole ratio. So ammonia to NO is 4 to 4. So each 4 moles of ammonia gives 4 mole of NO. Type. The 4 moles of ammonia, their mass is 4 multiply 17. This mass of ammonia produce 4 moles of NO. If I don't have this mass, I have 8 to 4 gram, how many moles it will give? Cross multiplication, and the number of moles will be, yes, you make it with me. So it is, no way, 48, is it 48? Yes, it is 48.4. What is the unit? Yes, mole. Type. If he doesn't want how many moles of NO produced, if he wants what is the mass, this means, pay attention, I will convert also this 4 moles of NO into mass also, and I make it mass to mass ratio. But he gave me mass and he wants number of moles, so I make it mass mole ratio. Okay. Another example. He gave me this equation, 10 react with hydrogen fluoride to give 10 fluoride plus H2. Balance the equation before anything, so I have to multiply this by 2. And then I put the mole ratio before anything. This is the mole ratio. 1 to 2 to 1 to 1. And then I see what does he want. How many grams of tin fluoride is produced by the reaction of 30 gram of hydrogen fluoride. Here, I need to convert the mole ratio into mass ratio. Okay, what is the mass ratio? What is the molar mass of tin? Let me open the periodic table. Tin. Yes, it is 50. It's not 50, it's 118.7. Let us make it 118.7. Let us make it 119. 119 gram of tin gives, here the ratio between what and what? How many grams of tin fluoride produced by HF? Okay. Type hydrogen fluoride, it's 2 multiply 2 mole multiply hydrogen 1, and the fluorine is 19. 1 plus 19 يعني 20 gram. Okay, so this gives 10 fluoride 119 and 19 by 2. 19 by 2 and add 119. I'm approximating the numbers, okay? 157 gram of tin fluoride and 2 gram of hydrogen, okay? What did I do here? I converted the mole ratio to mass ratio, okay? Each 119 gram of tin, which is 1 mole, react with 40 gram of hydrogen fluoride, which is 2 mole, to give 157 gram of tin fluoride, which is 1 mole, and 2 gram of hydrogen, which is 1 mole, okay? He gave me the mass of what? He said that 30 gram of HF produced, reacted 30 gram instead of 40, 30 gram instead of 40, okay? And he wants how many grams of tin fluoride is produced, how many gram of tin fluoride is produced, okay? So I say 40 gram of HF gives 157 gram of tin fluoride. اللي هم 2 moles of HF gives 1 mole of tin fluoride. So if I don't have 2 moles, if I don't have 40 gram, I have only 30. So how much tin fluoride will produce? So cross multiplication, do it with me. 157 divided by 40, the answer will be 117.75. Make it with me and try to get your answer. If your answer is 117.5 gram, so your calculation is correct. Okay, طيب. This is all for section 2. Let us move to section 3, but this is okay for 2. Okay, I'm in the same video. Okay, section 3 has nothing to add more than the limiting reactant and percent yield. What is the limiting reactant? Yani, for example, if I have this silicon dioxide plus 4 HF hydrogen fluoride, okay, they will react to give silicon fluoride, and water. And here I think the equation is balanced. You have 1 silicon, 2 oxygen, 2 oxygen, 4 hydrogen, 4 hydrogen, and 4 fluorine and 4 fluorine. So the equation is balanced. And again, before I read anything, okay, make the mole ratio. So the mole ratio is 1 to 4 to 1 to 2. So each 1 mole of silicon needs 4 mole of hydrogen fluoride to give 1 mole of silicon fluoride and 2 moles of water. Type, if 6 mole, what he gave me gave me. He gave me 6 mole. This example is found in page 313 in your textbook. He gave me 6 mole of hydrogen fluoride added to 4.5 of silicon dioxide. Okay. Listen to this. If I use 4.5 mole of silicon dioxide, by the mole ratio they need how many moles of hydrogen fluoride multiplied by 4, right? This is the ratio. So this means that 4.5 needs 4.5 times 4 means 18 moles of hydrogen fluoride, right? If I have 1 mole of silicon dioxide, this needs 4 mole of hydrogen fluoride. So if I use 4.5 of silicon dioxide, so it needs, multiply this by 4, means 18 gram of hydrogen fluoride. Actually, he didn't give me 18 gram, he gave me only 6. So this means that hydrogen fluoride is the limiting reagent and the silicon is the excess. Okay? So build on the limiting, use the limiting, okay? Yani this means that this 4.5 mole does not have enough hydrogen fluoride to react with. But 6 mole of hydrogen fluoride, actually according to the ratio, they need only 1.5. And you have already 1.5 and more even from silicon dioxide. So this means silicon dioxide is excess reagent and the hydrogen fluoride is the limiting reagent. So after you make the mole ratio, check what exactly he gave you. And from this you can get what is the limiting found in shortage and what is the excess found in palanty. And build on that in limiting, that in shortage. So which is the limiting reactant? طبعا the limiting reactant is the hydrogen fluoride. Okay, another example. Page 314 in your textbook. He gave me this equation and the equation I will give it to you, balance it. Iron react with water to give iron oxide plus hydrogen. Okay, the equation is balanced, so you have 8 hydrogen here and 8 hydrogen. You have 4 oxygen and 4 oxygen and 3 iron and 3 iron. Yes, the equation is balanced. Yes, before doing anything, have mole ratio. The mole ratio is 3 to 4 to 1 to 4, right? Means that each 3 moles of iron needs 4 moles of water. Type when 36 gram of water is mixed with 67 gram of iron, what is the limiting? He is talking about masses, so we need to convert this into mass. So the mole ratio will convert to mass ratio. Type what is the mass of 3 moles? So 3 multiplied by, what is the molar mass of iron? I will get it from the periodic table. Iron, iron, iron. It is 55.8, let us say 56 gram of iron needs 4 multiply 18 gram of water. Okay, type 3 times 56, how many gram? You do it. Okay, yes, 168 gram of iron react with needs how many? 72, yes, gram of water. This is the mass ratio. He didn't give me this. He gave me that 36, he gave me 36 gram of water and 67 gram of iron. 67 gram of iron and 36 gram of water. Okay. If I have 36 gram of water, and you have this quantity, means I need half this quantity, right? Half the 168 is, I believe that it is 84, صح? Yes, it is 84. Okay. طيب, here I have 36 of water, but I have only 67. See? So the 36 does not have enough iron. So this iron will be the limiting, and this will be the excess. Right. After I made or I figured out what is the limiting and what is the excess, I will work on I will build on the limiting. Okay? So I will consider that I have only 67 grams of iron. Okay, so I will get what is the amount of water it can produce, or how much iron oxide it can be produced. I mean how much water it can react, or how much iron oxide it can produce, or how much hydrogen is produced. I will build on the limiting. So this is why I will work on the 67. Now I have 67 already. Okay. So if 67 gram of iron, okay, needs or produce how many gram? What is the mole ratio? Let us get to this again. What is the mass of iron oxide produced? So this will be 16 multiplied by 4 plus 56 multiplied by 3. Please help me to get the molar mass. Again, 56 multiplied by 3 plus 64. It will be 232 gram, and 4 hydrogen means 8 gram. Okay, so this is the complete mass ratio. So if I have 186 gram of iron, means I will this will produce 232 gram of iron oxide, but I actually have only 67. So how much mass of iron oxide? This will be cross multiplication. So back here I have 168 gives 232, right, from the previous one. If 168 gram of iron gives 232 gram of iron oxide, but I actually have only 67. So how much? This how much will be cross multiplication. 232 multiply 67 over 168 gives 92.5 should be okay. Yes. No, it's 90 something. Okay. Again, back to previous one. I want to make sure of this. 64 plus 168. 64 plus 168. Yeah, so 232, we are right here. And 56 multiplied by 3, yes, it is 168. Okay, so here. Yes, so yes, so it is 90 something. Maybe it is slightly different from the answer in the text because I approximated. So it will be gram. Okay. Percent yield, last thing. He can ask you the percent yield and you will make all your calculation exactly as we did, and you will add only one step. You see this unknowns we have, this is called the theoretical yield. The yield or the value he wants that you make it with your calculation. The actual yield can be less than this for many reasons. Maybe you didn't give enough time for the reaction to complete. Maybe some reaction are reversible, so the products produced, some of it return back to reactant again, and like this. So maybe this product is a gas and some of the gas evolved. So there are many reasons to make the actual yield is less than the theoretical yield you just made here by your calculation. So the percent yield, if you want the percent yield, you will add only to your steps before, you will add this step equal the actual, and he will give it to you, you don't know what is the actual, okay, over the theoretical yield, okay, the one you made your stoichiometric calculation together, multiply 100 to make it in percentage. That's it. Good luck. Please pay attention. It is very important to solve the problems and the questions and the website, whether via VLE or worksheets. It's also important to solve the workbook, and if you don't have anything you don't understand in the theoretical part, at least this explanation can help you, and most of luck for exam.